Hi, my name is Emily Weber. I'm a machine learning specialist solutions architect at Amazon Web Services, and today we are going to learn how to train and tune machine learning models to the highest accuracy on Amazon SageMaker. So let's get started. So in the session here today, we're going to learn about Amazon SageMaker Studio, in particular, how Studio is decoupling environments, letting us scale and manage these independently. We're going to look at training and tuning jobs on SageMaker. We're going to learn how to find, tune, and track our models using SageMaker Debugger and experiments. We'll look at training hundreds of models using SageMaker Autopilot, and we'll close it out with a demo. So let's get started. All right, so SageMaker Studio. So SageMaker Studio, if you're not familiar, is based on Jupyter Lab, right? So we've got our IPython notebook file here. And in particular, it is a fully integrated machine learning IDE, right? So rather than needing to go hither and yon, left, right, and center, as we're trying to be proficient in terms of our machine learning development, SageMaker Studio is actually going to bring this all right to our fingertips. And so we're going to have a number of notebooks, a number of widgets, all these features and capabilities that are built out for us. And then on top of that, we're actually going to look at these new dedicated instances that are going to run inside of our Studio domain. So the visual here, so we're looking at this IPython notebook file over here on the left-hand side. We're going to be able to track and run all of our jobs using SageMaker experiments, actually. So we have this nice little view down here on the right-hand side where we can see our trainee jobs. We can track all the lineage for our trainee jobs. We can actually compare different training jobs against each other using this trial component chart here. So we've got a variety of widgets over there on the left. You're looking at Git branching, you're looking at environment management, experiment management, all sorts of goodies. And so to really break this down here, to take this home, so SageMaker Studio starts with you, right? Starts with a data scientist, machine learning engineer. There are a couple ways you can get into SageMaker Studio. First one is enabling your IM execution role. That's a couple clicks in your AWS console there to get that up and running. We can also integrate SageMaker Studio with single sign-on, actually. You can take a look at setting that up with Okta using AWS SSO, and that's going to give us a single click experience, right? So one click, and then you can jump into your Studio domain. We're going to see notebooks turning on very quickly with SageMaker Studio. So in SageMaker notebook instances, we saw notebooks take roughly at least 3 minutes to turn online. And so with SageMaker Studio, you're looking at come on in seconds to minutes, so much faster. And so once we get into our domain, we're going to be, again, given a variety of features and capabilities. They're all built out for us, pretty much ready to go. So you're looking at Autopilot, Experiment, Debugger, Model Monitor, Versioning, Endpoint Management, Elastic Notebooks, all sorts of good things. Now, the thing to keep in mind here, particularly if you're familiar with SageMaker Notebook instances, is that all these features and capabilities that we're learning about, these are all backwards compatible, which is to say you can still use them on a notebook instance. They're just going to be a little bit easier on Studio. They're just going to be already built, already packaged, already ready to go, and we have to literally write less code in order to use them. And now, so once we're inside of this domain, we're literally going to create dedicated instances per notebook, per IPython notebook file that we're running, which is to say, as a developer, as a data scientist inside of my Studio domain, I can literally create n number of notebooks. Right? I can run n number of instances all inside of my single dedicated view. So it's really fun to use. So Studio comes really nicely with sharing, right? So we're going to look at a one-click sharing experience where we can create these snapshots and then share the snapshots with other developers in the same domain. We can also easily upgrade our notebooks actually. So when you're building a complex feature engineering step and you need to upgrade that instance. So say you're doing a really gnarly for loop with some complex transforms and you'd love to just run that on a GPU, you can actually do that in a single click. And so here's a view of your one-click instance upgrading. Right over here on the top right-hand side, we're just going to click on that little infrastructure button, and that's going to show us all the instances that come out of the box with Studio. So you're looking at 4 instances that are fast startup, So those are going to come online in seconds to a few minutes. Some of the other instances may take a little bit longer, but again, there's just a huge variety of instances. And remember, all of these instances are available inside of a single IDE. So all inside of SageMaker Studio, you have this, tremendous variety of instances that we get to play with. So now let's actually compare this with some ways that machine learning is commonly developed, right? And so the most common place that machine learning is developed today is actually a laptop. And there are some upsides to developing on our laptops. Right, laptops are super flexible, they're very personal, and it's so easy to get started, right? It's effectively easy to get started on our laptops. However, there are some downsides to literally doing our development on our laptops. Obviously, the number one being that it's challenging to scale on a laptop, right? If you're trying to pick up an object in the memory that has more data, than fits in your computer, it's going to break. That machine will shut down. That is what happens. Obviously, we can't run those in production, but more importantly, in order to experiment, in order to be a good data scientist, to be efficient at our jobs, we have to be constantly looking at all these new things, right? Looking at new open source packages, new toolkits, new frameworks, new this, that, and the other. And in order to do those experiments, guess what? They have all these different requirements. They have package dependencies, software versions, and these things can so easily conflict with each other. And so I don't know about you, but for me, every time I go to work on a new project, it's really frustrating if I need to literally update, apt-get, update virtual environment, pip install, all my packages yet again and make sure that they're not conflicting. So it's tough. Now, the next place machine learning is commonly developed are obviously on servers, right? And while servers may feel familiar and they may seem less expensive up front, actually, when you take the full picture into account, they're actually a lot more challenging, and then due to being more challenging, they're actually more expensive in the long run. The number one issue being that servers go down. It's really challenging to maintain a server that's actually up and running and an application that's highly available. And in particular, you're always stuck in this place where you're constantly either over or under utilizing your resources. So let's say we've got a really, successful hiring season. And so we've just onboarded a number of new data scientists, and they're ready, they're hungry to work, to solve a complex problem. But it turns out we actually don't have the compute for them. We literally don't have enough servers. So what do? We go through procurement. We have to literally wait for those servers to get ordered, shipped, racked, stacked, installed, provisioned. And that might actually be 6 months. That might actually be 6 to 8 months for those servers to actually arrive. And then what are those data scientists doing? All of them are attacking the small number of resources that we have. And then that's going to increase the likelihood that those servers go down because they're being, again, overutilized. And then let's say that out of frustration, these data scientists maybe jump over to a different team because they want their own machines. And so they move on to a different team, and now suddenly those servers that we ordered are being underutilized, right? No one is touching them, they're underutilized. And so the core value proposition of the cloud, and in particular Amazon SageMaker in the case of machine learning, is this elastic capability, right? Where we can actually spin up more compute resources exactly with the needs of our business, and then scale those back down exactly with the needs of our business. So the big thing to take home here is that SageMaker and the AWS cloud are bringing elastic, dedicated compute for each person on your team, for each project that person is working on, for each data set that person has access to, and for each step in your machine learning lifecycle. And so that is why there are so many, there's so much action and so much activity around the AWS cloud in regards to machine learning. So now let's take a look at SageMaker training capabilities. So we come to find out that there are these things called algorithms, right? There are these models that are really well designed to solve specific problems. On SageMaker, you're looking at 18 built-in algorithms. And again, these built-in algorithms solve a variety of purposes. They're a really great way to get started. I actually have customers who run in production with these built-in algorithms because they have to do less work. Right? They don't have to focus on constantly rewriting that algorithm from scratch. They can just pick something that works really well for the use case and then actually deploy it sometimes in the same day. if they're moving really quickly. But the thing to note here is that there are many ways to train models on SageMaker. Again, there are a variety of ways that we can train models on SageMaker. By no means are you locked into just the built-in algorithm, although they are a good place to start. Two other common ways of doing this are called script mode. And so script mode is where we're actually defining our own model in a Python file. So we're going to bring in a Python file that's defining our model, and that can be TensorFlow, MXNet, PyTorch, Chainer, Scikit-learn, Apache Spark, XGBoost, SparkML, a lot of options there. So we're going to define our model in this Python script, run it in a Docker container that is managed by SageMaker, that's actually managed by AWS, and believe it or not, we get to bring all of our own packages. So all of our requirements, all of our software dependencies, we're just going to define that in a requirements.txt file, land that in our estimator, run our job, life is good. In the event that you're working on a model that does not have a built-in container, like say R, Scala, Julia, then you're looking at a Docker file. You can actually write your own Docker file, package up all your software, all of your content, literally build a Docker image locally, push that out to the Elastic Container Registry on AWS, and then point to it on SageMaker. And life is good. We go on our merry way. So here's a view of training with a built-in algorithm. So again, it's just an image. We're going to point to this built-in algorithm here, in this case, blazing text, because we're solving an NLP problem. What do you know? So we're pointing to blazing text. And again, we're using, in this case, the SageMaker Python SDK to establish a container variable that is pointing to that image, actually. So it's literally just an address in ECR. We're going to set up this estimator locally. So again, the estimator is really packaging together all your content before you run your job. So you've got your container execution role, and we are actually, again, defining a new EC2 instance. So again, we're developing on Studio, on our notebook instance, on our local laptop if we have it configured. And what we're going to do is actually run a new job. We're going to actually turn on a new EC2 instance that is dedicated to our model. And in this case, it's a C4 And this guy is going to be up for the number of seconds our model is training. The moment our model finishes training, that guy's going to come back down, life goes on, and we're done, right? Because we trained our model. So we've got 30 gigs living on that instance. We're specifying our max runtime, file mode, S3 output, SageMaker session, yada, yada, yada. Hyperparameters, because we're looking at a deep learning model, and what do? We call model.fit. So again, model.fit, and we're actually running a new job. Here's another view of doing this in a similar way, except where, again, we're bringing our own Python file. So this is script mode. This is script mode using the built-in TensorFlow container. What do you know? So we're going to import this TensorFlow object. So we're importing this TensorFlow estimator, as it were, right here. We're going to package up our local entry point script right here. Same flow, SageMaker execution role. This time, look at that, 2 EC2 instances. So we're running a distributed job. We're sitting pretty on some GPUs right there, running TensorFlow 2.1, Python 3. We're going to be using the parameter server here for our distribution method, model.fit. We're on our merry way. Now you're telling me, Emily, this looks great, but what do I do when I have a version of a framework that's not supported? So it's actually really easy, because you can just define that in your requirements.txt file. So again, SageMaker is going to look by default in your source directory. So when you're dropping in an entry point and you actually have a whole repository of stuff, of code that you want to run up there, SageMaker is going to by default look in your source directory for a requirements.txt file. When found, what's it going to do? It's going to loop through that and get those things installed. No problem. So we've talked about these training jobs. What the heck are they? Here's what they are. So again, we're going to be on our notebook instance, on Studio, on our laptop, and we're going to get our estimator defined. We're going to call model.fit. We're going to fit this model, which sounds familiar. Something different is happening though, believe it or not. So we're going to land our data in S3. You do have a variety of options for that. By and large, we're looking at S3, but especially if you're trying to scale up a training job, check out FSX Reluster. It's going to save you some time there. So we're going to land our data in S3. And then what's going to happen? What's going to happen is we're turning on, again, new EC2 instances. So in this case, we're turning on 2 EC2 instances as defined by that estimator down below. And SageMaker is managing the copy from S3 to this new cluster on our behalf. And so it's copying that out. And then what's this? That's the Elastic Container Registry. So that's, again, the actual content for the built Docker images that either, again, we actually built locally and then pushed, or we are actually bypassing when we're bringing script mode, or we're just using an off-the-shelf option with a built-in algorithm. And so that's, again, SageMaker is going to download that model to our cluster. It's actually downloading it to that training job. And then we can close our laptops and go away. We can have lunch. We can take a break because, again, that's actually training. That model is actually being trained, and we have full visibility. We can view all the logs, we can view all the metadata. All of that content is stored for us. SageMaker is actually going to store all that content by default. We can version it just by versioning our S3 buckets, all sorts of good things. And then once that's finished, the trained model is getting written to S3. So that trained model artifact, defined however we defined it, is going to get landed back in S3 on completion. And we're going to go on our merry way. So a good thing to know in terms of saving money while running on SageMaker training is something called spot instances. And so spot instances are great ways to save costs on our SageMaker training jobs. These are supported natively in SageMaker training. And essentially what's happening is that AWS has a lot of EC2 instances. Let's get real here. They've got a lot. World-leading, cloud provider by a wide margin. Turns out they have a lot of virtual machines. And so what happens is that not all of those virtual machines are being used all of the time. And so the ones that are not being utilized are actually available in a different mode. They're called spot. It's called spot. It's in, distinction to, say, on demand. And so when we're using an instance on spot, it's a lot cheaper. There is a chance that our job will get interrupted. And so that's why it's really nice to have a managed spot experience, because if and when that job does get interrupted, SageMaker is actually going to manage the movement over to an on-demand job for us. So pretty nice there. So we can bring our own training script and still leverage the SageMaker hyperparameter tuner. So there's a built-in Bayesian optimization on SageMaker. You can also use random search if you want something to go a little bit quickly. I've also seen some DIY approaches. You can have some fun there. And essentially this is going to operate like an orchestrator. It's going to run n number of child training jobs and look at each of those in parallel, figure out what the current metric result is on your validation set, land that in a Bayesian optimizer, and then reinitialize your next n number of child training jobs. And here's an example of bringing our own PyTorch model and then plugging that into the SageMaker hyperparameter tuner. So on we go. SageMaker Autopilot. So, SageMaker Autopilot is really great for citizen data scientists, analysts, business intelligence engineers, or scientists from other domains who still want to take advantage of some of the cutting edge capabilities in machine learning, in particular around regression and classification, but who maybe don't really want to manage all of the ML, right? They just want to take advantage of it. And so SageMaker Autopilot is a great case for individuals like that. We need three things. We need to, number one, get our data in S3. Number two, point to the target column, so identify what we want to build a model around. And then number three, we're going to run that on SageMaker. That's all we need to do. So again, Autopilot is generating notebooks for us. It's actually going to be generating content and code. So it's generating notebooks across data exploration, data transformation. We've got a nice little script there that were generated for us. And then we have what are called candidates. And a candidate is a unique combination of a feature engineering strategy with a model tuning strategy. And in SageMaker Autopilot, by default, we're going to get 250 models trained. So quite a few models that are trained there. In Studio, we get a really nice dashboard that Autopilot creates for us, telling us what stage our model is in, moving all the way from analyzing data to performing feature engineering, tuning the models, and then showing completion. And again, you can see on the top right-hand side there, you can just open up your candidate generation notebook, open up your data exploration notebook. All of those tuning jobs, we can view the full lineage on. We can see all of the data transformation, all of the analysis, all of the model training, tuning, batch transform, all sorts of good things we can also right-click and deploy. So we're going to do one right-click on a single tuning job, or the best one once the job is completed, which SageMaker will tell us which one is the best. And we're going to right-click deploy. And guess what? SageMaker is going to build an inference pipeline dedicated to that. So we can build our own inference pipelines in SageMaker, but with Autopilot, what's going to happen is it's going to take that ETL script that it generated for us and then drop that as the first container inside of a series of containers. So inference pipelines, which it creates for us with a single click, which isn't that bad. And so here's a case where I was working with a customer on estimating shipping date. So they needed to know when their orders were likely to ship, and their current system could be off by an order of months. And so we did some lightweight feature engineering, dropped this into Autopilot, and on our first go, in the case of regression, we got an RMSE of 69 on the validation set, which when we aggregated this out to the week level was less than 1% wrong. So again, the orange line is the actual shipment date estimation, and the blue line is actually what Autopilot predicted, right? So it's getting those huge peaks, those huge valleys. And again, that was aggregated to the week level, and then throughout the course of a year was pretty accurate. So not bad for like 20 minutes of work. All right, so next up. So now we're going to take a look at SageMaker Debugger. So Debugger is really a great way to analyze our deep learning models on SageMaker. So also XGBoost. But so what's going to happen is we're going to define what's called a debug hook. Your debug hook, 3 lines of code. Essentially, that's just setting up the content for this job. So we're going to land that debug hook inside of our estimator. So that estimator, we've got the debug hook in there. Moving on. We're going to run our training job. Same flow as last time. The debug hook is actually listening to events. It's listening to events. It's recording tensors on that training job. And then as soon as it has some tensors recorded, it's going to land those back in S3. Optionally, we're going to run another job there, which we don't have to pay for. So Debugger will actually run online and optionally analyze these rules for us. It has up to 18 built-in rules. We can also download those tensors, download those gradients, and then actually plug them into a nice visualization toolkit. And so here's a way you can visualize your own deep learning model using SageMaker Debugger. So this is a vanilla MNIST model. Obviously, we can see that the dark level, the dark colors here in this deep learning model are being less activated. Those are gradients in this neural network that are being less activated to perform this classification, whereas the light color is being more strongly activated. And so this is a nice way to actually understand, precisely how our model is training, and also improve the architecture of it, improve the neural network itself. There's a nice example where you can look at iterative model pruning, leveraging SageMaker Debugger. Another option here is class activation maps. So if you're not familiar, this is a way to, same flow, plug in Debugger, pull the tensors down to our local IDE, and then set these up in what's called a tensor plot. So this is a script you can take a look at. And essentially, we're going to find out which areas in that 2D array, so those incoming images in this case, which we're going to think about in a 2D array, SageMaker Debugger is going to tell us precisely which pixels and which tensors are being most strongly activated to produce that final classification. So pretty neat. And with that, let's check out the demo. All right, so now we're going to do a quick demo of SageMaker Autopilot. So as you remember, SageMaker Autopilot is really purpose-built for data analysts, business analysts, data science engineers, folks from other disciplines, really anyone who wants to work with data but may not want to really go super deep into the weeds on the machine learning science and some of the details there. But so what we're going to do is again leverage SageMaker Autopilot for regression and classification cases, and then we're going to get full transparency across the board because Autopilot is actually generating notebooks for us. It's actually writing code on our behalf, and then it's going to help us do a one-click deploy, both on that ETL for the feature engineering and for the model training and tuning and inferencing. So let's check this out here. So First off, you can see we're in SageMaker Studio, right? So we've got all of these handy dandy widgets over here on the left-hand side. And the notebook that we're working with comes with the examples, right? So just straight from GitHub. And so let's step through this here. So again, we're going to, in this case, train a classification model. So this is going to be a binary classifier telling us the likelihood that a customer is going to be churning, is going to leave our platform. So we're going to import the SageMaker Python SDK. We've got Boto 3, we've got our region, SageMaker session, we've got our buckets. So that's your default bucket. You can point to one of your choice. We've got pandas, NumPy, matplotlib, life is good. We're going to download the data set. So this is just a vanilla wget here. If you didn't know this, you can actually click this little blue highlighter bar. So click the blue highlighter bar on the left-hand side, and that cell is going to collapse. It won't go away, but the content of the cell will be minimized, so you don't have all those details just glaring at you if you wanna actually close those out. So pretty nice. Next, we're going to pick up this data set into, what do you know, a pandas data frame. And then let's check this out. So we've got all these rows, lots of categorical features, some running variables in there. And then over here on the right-hand side, this pesky churn column, which is going to let us know the target column. So again, this is what we're going to be training our model against, so to speak. And so in this notebook, we do some splitting. Splitting is actually optional with Autopilot, and that's because we can, again, just leverage the default settings in Autopilot, and it will actually look at performance on its own validation set. We just have to supply the train set, but we'll keep the test file here for locally for testing purposes. And then what are we going to do? We're going to write 4 lines of code to get this job set up here. So we're going to import AutoML from SageMaker, and then we're going to pass in that execution role, that column name, so churn, base job name, SageMaker session, which we got through the SDK, and then the max candidates, which is how we can configure the total number of jobs. And so max candidates there, and then this is a complex maneuver. It's not, actually it's one line of code, automl.fit. So automl.fit, and we're again passing in the local training file, as it were, and then SageMaker is copying that out to S3 on our behalf. And then what do we want to do? We want to view this, right? We want to track this. We want to see what's going on. So we're going to click on this experiments tab, this little experiments widget. We're going to give that a click. And then we want to actually expand this, right? So we've got this little panel. We're going to just click and drag. So click and drag this panel, and then we can resize these. And so I'm going to refresh. I'm going to refresh on my experiments, and then I'm going to actually right click on this. So I'm going to find the last job I ran. I'm going to give this a right click, and then we're going to describe AutoML job. So describe. Looks like we are just starting model tuning here. We finished up analyzing the data, finished up feature engineering, and we just moved into model tuning. So any minute now, we'll actually get some jobs completed, and there we go. Actually, that was already ready to go. Just waited for a refresh. And so here's the best job that we found. This was obviously ran quite a bit ago. So the job finished up about 5 minutes ago. Best tuning job. And here's the performance as defined by F1 score on our validation set. We're going to right click. And then we're going to, a couple options here, so we can open in trial details. And so trial details really gives us a lot of visibility into the metadata, right? We can see the trial stages, we can see the tuning job, transform job, training job, batch transform job, processing job, all sorts of good things. We've got all of our metrics, parameters, artifacts, data stored in S3, so all of these we can visualize. So we can deploy this model, or we can set up a SHAP explainer and deploy the model all at the same time. So let's check that out. So notebook number 2, we're going to set up a SHAP explainer around that autopilot endpoint. So let's check this out here. So we're going to actually attach that name. So the previous job name we just used, job.attach. So we're going to pass that in, And then let's deploy this. So model.deploy, still one line of code there, maybe two if you count the wrapping. But so that's going to take one M52XL with these inference response keys, model.deploy. And then we're going to set up a local class here, so local AutoML estimator, to wrap around that predictor. And then we're going to send some data against that predictor. So we'll run some predictions, and then yeah. So there we go. So we've got this predict proba to get our predictions, and we're gonna drop this in SHAP. So then we'll be able to leverage our SHAP explainer to see the exact features that are driving the predictions from our model. And so that's available both at a local in terms of a single prediction and at a global level for across the entire data set. And so with that, thank you very much. I hope you enjoyed the SageMaker Autopilot demo.